Good morning. My name's Iain Russell. I work in the development section at ECMWF. I would like to thank my colleague Chandra Curtis, who's also, I'd say, the major Metview developer, in fact. So I think you've been learning a lot about different tools like Mars Access and EC codes and looking at grib and buffer files and so on. I think you've kind of been doing it the hard way so far. I think Metview gives a nice interface onto these things and pulls a lot of these features together into a nice both graphical and Python interface that lets you explore your data in quite a nice way. So this morning is going to be, let's say, roughly half an hour of me talking and about an hour for you get your hands onto a practical session with Metview. That's assuming that you can all actually log into your virtual desktops. But we've still got half an hour before we get to that stage. So, what is Metview? So, it's workstation software. It's running on a desktop. It's not a web application, but you run it physically on your machine. It works on Unix systems, basically Linux and Mac OS. So I can run it here on my laptop, or we can run it on the Atos HPC. It basically works the same way. It's a development from ECMWF. It builds on a whole bunch of other ECMWF libraries. In fact, I've got a little diagram coming up to show you what it builds on. So it doesn't stand completely by itself. It's, we don't reinvent the wheel. Open source, you can get the source code. It's Apache license, so you can basically do with it what you want. And its main pillars are data access, like retrieving from Mars, for instance, data processing. It's got so much data processing. Visualization, of course, these things tend to come together, and they tend to come in that order as well. And you've got different ways of interacting with it. It's got this user interface, which is icon based. And we have these scripting languages. Macro was a language written originally with Metview. Nowadays, we tend to push people towards Python because it gives you more flexibility, because you can interact with all the wonderful Python libraries that are out there. Whereas if you use macro, you're kind of in a more isolated environment. You can only use the Metview functionality. So we push people towards Python nowadays. And Metview was started off as a cooperation project with the Brazilian institute, INPE. So in fact, it's quite mature now. This year, possibly even this month, it's 30 years old. And it's basically been serving the same function all that time. It's still in use daily by analysts and researchers outside ECMWF, member states, cooperating states, universities, commercial users. Basically, when people encounter grib files for the first time, I think often Metview is the nicest way they can start to use them. And then internally, we have some quite large developments that are built on top of Metview. So we've got a thing called the Diagnostics Toolbox. When we run OpenIFS workshops, they use Metview there for the students to post-process and analyze the data and look at case studies. And we've got a big sort of verification package called Quaver, which is also written on top of Metview because it provides very convenient data access and processing and plotting facilities. And then EC charts, if you use that, it's not exactly based on Metview, but the architecture is it's inspired by Metview, let's say. Well, written by the same person, in fact. It does have some of the same code, so it's kind of like a Metview on the web, but it serves a slightly different purpose. So in terms of the packages here, you'll recognize some of these. So if we say we've got Metview on top, then in terms of data decoding. We're using EC codes to handle our grib and buffer data, of course. We got a sort of observation format called ODB, and strangely enough, the package to handle that is called ODC. And then we can also support other data types like NetCDF. We've got sort of observation types like geopoints as well. We can read grids and crop the data. So if you're starting off on a sort of octahedral Gaussian grid, and you just want a 1 by 1 degree grid over Europe or something like that, you can do that in a one-liner in Metview, and that is using these libraries called Mir and Atlas underneath. They're also ECMWF libraries. For plotting, we are using Magix, which is also the graphical engine behind EC charts. So again, another ECMWF package. And data access, this is like retrieving from archives such as Mars and CDS. Of course, you can access grib files and so on that are on your hard disk. We've got if you've got like a web map server somewhere, you can also import those layers into your plot in Metview. And if you've got files sitting around in URLs, then of course we've got functions to download those and decode those from remote locations as well. So in terms of how you use Metview, what you're going to be seeing today primarily will be the user interface. One reason I think it's nice for people to start with the user interface is not only is it kind of quite friendly, but I see a lot of people getting into Metview through the Python interface, and then they sort of come to me to ask how to do things. And usually, in fact, the user interface tells you how to do things. I think it's, if you start using the user interface, it gives you a bit more knowledge of how to use Metview. So it's for interactive investigation of data. Each icon you see on the screen represents something like a grib file or a buffer file, or like a contouring definition, like a color palette, that sort of thing. So all of these are represented as icons. If you have icons that represent processing steps, then you can also chain those together. So you've got a chain of processing steps that occur one after the other on the data. So yeah, the example I give there in the slide is you've got some grib data and you want to select just the fields that correspond to a given date, and then pass that on to the cross-section module. And then our Python interface, this has basically everything that you can do in the user interface with icons can also be done in Python, but it also has a lot more functions that we don't expose in the user interface as well. So if you want to get into sort of serious programming, then the Python interface is the way to go. You can run Python code directly from the user interface, or you can use it just the same as any other Python library. It's similar to EC codes in the sense that you need to have access to the Metview binaries somewhere, but as long as they're in the path, then if you've got the Python interface, Metview just becomes any other Python library. One of the really nice things I like about it is that you can play around with icons in the user interface. You can sort of tweak things interactively, get your plot looking nice, and then you can easily generate the Python code from those icons to have something then you can sort of run every day or something, producing your operational plots. And then the last point is that it can basically do everything that Metview macro could do, but because we are trying to push everyone towards Python now, at the end of this year, we are calling a feature freeze on the macro language itself. So we just encourage all new users to use Python, not the macro, because we are adding new things to Python, but not to macro. Okay, so this sort of things you can do with grib data. is, yeah, you can plot it, and we have this nice interactive plot window that shows you can see statistics and histograms of your data in there. Various nice features. You can examine. This is a really nice feature. This is basically grib dump and grib ls put together on steroids in a user interface, which lets you, I think, very easily see the contents of your data. Yeah, filter data, select fields that match certain criteria, regrid, as I mentioned, cropping and masking your data, maths and Boolean sub-operations. These are ones you would tend to do in Python rather than with the user interface. And then we've got the more specialized things, to our sort of domain of meteorology or atmosphere, cross sections and thermodynamics. We've got functions that convert between different vertical level types of, for instance, pressure levels and model levels you can convert between. Buffer data, you've had the fun of experienced buffer data, so we can plot that. And if buffer can be arranged in lots of different sort of styles. I can have the templates for buffer files, and if it's one of the ones that we recognize, then we can plot these. So if it's like a sort of sign up message, then we can plot these directly, which is nice. We've got examiner, again, equivalent of buffer dump and so on. A nice interactive widget. Quite often with buffer data, you are looking for something very specific from it. You want to take, say, 2-meter temperature from it. So that's what the filtering is. This is just like buffer messages that fulfill certain criteria and extract a particular variable from there. And then we would tend to convert those to our own format called geopoints, which is just basically a list of lat longs and values. And then once you got that, you can plot those quite easily. And you look at those right-hand plots; those are plotting geopoints. That's just one variable out of the messages. We can plot septigrams and things from buffer as well. Okay, and then NetCDF, we don't have so much support for that. Traditionally at ECMWF, we haven't used so much NetCDF. We see it appearing a bit more nowadays, but it's still not our primary format. But we can plot it, and so whether it's a map or something more like a sort of XY Cartesian plot, we can plot most forms of NetCDF. We've got a little examiner widget. We do like those. And then, yes, you can take your NetCDF variables and you can do some maths on them, extract their values and, plot time series and so on from them. And then ODB, I'm not sure if you've experienced ODB yet, but it's another observation format, but it's simpler than buffer. It's really just columns of data. It's a bit like a binary CSV, if I may simplify it like that. So we can plot our ODB data. We've got an examiner, of course, so you can inspect what you have. That's quite often actually one of the first things you want to do when you get some data is just have a little look and see what's actually in there, what are the variables called. So these examiners are really useful. And then you can filter your ODB data to get just the particular columns and time ranges that you want. And you can convert to geopoints. It's a format that we have a lot of functionality for. So as long as we can convert other formats to geopoints, then we can do some nice things with them. And then geopoints itself looks a bit like this. It's largely like a CSV file with columns of sort of lat long values with some other metadata in there, which we can plot, as you've seen. We've got an examiner, of course. We can filter these, so extract just certain observations. We can do our sort of maths operations on them. Got geographical functions, since we know the coordinates. And we also have a two-way conversion between GRIB and geopoints, which is quite nice. It's one of the ways that I've seen some people, if they don't really have the capacity, if they're using some software that doesn't really handle GRIB, then they can still maybe use Metview to convert it to geopoints. Then they've got it in a nice format that anything can ingest. And yeah, and we can also read some generic CSV files as well. And then just to point out that when we're plotting things, all these formats can come together however you want them, really. So I think here we've got 3 GRIB fields being plotted there, geopotential, precipitation, and temperature. And then on top of that, we've got some buffer data on top. And then optionally, you can get Metview to decide whether it is strict about these things matching in terms of date and time. I think by default, it lets you plot anything over anything, but you can also get it to kind of split things apart into different plots according to date and time. Usually, as soon as you plot something, you want to change its color. So we've got a few different ways of doing that. So, and this is one of the nice things about using the UI, is that you get these really nice widgets for defining color lists, which you can do this interactively, see how it looks, and then you can convert that into Python code. So we've got a lot of features for doing that. That's if you want to really define your own color schemes yourself. We also have a set of built-in palettes. A lot of them are from EC charts. I think quite a few are taken from matplotlib, and then there's a few others in there as well. So these are just supplying the list of colors, and then you still have to supply the mapping between the values and the colors. I mean, it'll do something by default, but you probably want something a bit more specific to your data. And then if we go one level further up again, we can not only take a palette from EC charts, but we can take a whole contouring style from EC charts. So EC charts stores, for temperature, it's got like, I don't know, 10 different color schemes or something. It's not just a color scheme, it's also how the isolines look. Are they dotted or dashed or solid, and so on? And how do the value ranges map to the colors? So we have imported everything from EC charts. You can choose from any of the styles there, or you can also ask it to decide for you, in which case it's going to inspect the metadata. It'll say, okay, this is 2-meter temperature. I know what style I should use for that. Or it might be that your parameter doesn't have an entry in EC charts, in which case you'll just get a default style. And then we can go one further up. This is really for EC charts fans. We have this icon here called EC charts, which contains not only the contouring styles, but also the data access as well. So if you've been on EC charts and you see some layer that you like, but maybe because EC charts only shows you current forecast data. If you want to see that same plot, but for data from last month, you can go into Metview and look at the EC charts icon there. You can select the layer, and then Metview is going to retrieve the right data for you. It might even be some post-processing it needs to do, but it handles that. And you get your data back, and along with the right plotting style for that data. One important concept of Metview is the view. Now, the first set of views we have, well, it's basically one view. I'm going to show first of all, which is our geographical view, which has various different projections. I think that's Mollwide there, or maybe Robinson, I'm not sure, they look quite similar. So we have a selection of these, or that's a polar stereo, of course, or like that's like a satellite view there, the GEOS. Quite a nice one here at the bottom left. Although it's just a cylindrical projection, it's worth knowing that we can, if you look at that, you can see we've got 1.5 Africas there. So we can do more than 360 degrees of longitude, which is really useful if you want to see all the oceans uninterrupted. If you don't want the sort of cut at the end of the page to interrupt your oceans, then you can actually plot something like this. So the ocean people use that kind of facility so they can see all their data clearly. Okay, then on Valentine's Day, we have a special one called Bon. And then, so these are all geographical view, but then we have a set of views called, well, we sort of refer to them as the analysis views, which actually do more than just reproject the data onto a map. These are things like a cross section, which takes your data, which is on multiple vertical levels. You supply a line, and this is going to extract the data along that line across all those levels and give you a nice plot. It can work out the orography for you and plot that curve as well. Yeah, we can extract data and plot time series in terms of XY curve. We've got Hofmollers, so if you've got time axis in your data as well. We've got various different types of Hofmollers we can do. We've got our thermodynamic diagrams, the ephigram, QT, and the hemogram we have. And then with a bit of extra work, you can have these nice sort of shaded areas and your wind barbs and so on the side. And we even have Taylor diagrams as well. In all these cases, you're kind of supplying your data, and the view takes care of extracting what it needs from your grid data and plotting it into this chart. And then you don't necessarily want just one view by itself. We've got a nice widget that lets you arrange however many views you want. So this is an example just of a cross section in the main view. The main view is the cross section view, and then we've got a map view in the top right to show where the cross section is occurring. This is one showing a tropical cyclone. You've got a map at the bottom of the or a time series of the minimum sea level pressure along the points of the track over time. Typically, so this widget for arranging the plots is very nice if you've got just a few. If you want to do something like a stamp plot for an ensemble with 50 members, it's probably easier to do that in Python. Something bigger plots you might want to do programmatically. Okay, then, so something else that we have some people using is the ability for Metview to interact with other with models. So, for instance, I think the first one we did was Flextra. I think this was a request from a member state that we be able to interact with this. Metview is able to get the sort of data that it needs. It prepares it, puts it into the right sort of grid structure for it. You can supply Metview with the parameters you want to run the Flextra model with, and it'll run it for you. It'll take the output, and you can plot the output in different ways, as you see there. The FlexPart, the particle dispersion model, is another one that we did, so it's quite similar. We have this thing internally called the single column model. It's used as one of the training courses that research do, where they use this to show what happens just at a single grid point. And they wanted to use Metview to be able to adjust profile curves and pass different data to this model and then plot the output. And then 3D as well. So Metview itself, I mean, it does flat plots, but there are different we've interfaced with different 3D packages over the years. The latest one is one called Met3D. We have some people in our evaluation section who are very interested in Met3D because it's very meteorological, and so what they asked is, because they don't want to leave their Metview environment and work in a completely separate package, they wanted to be able to use Metview to to retrieve their data, make sure it's in the right format that Met3D can handle, and then launch Met3D from within a Metview session. It's not something you'd be able to run at the moment because now that we're working remotely, it requires like a GPU-enabled VDI, which is, we have a couple of test machines, but it's not generally rolled out yet. But if you're running locally, then you and you've got a GPU in your machine, then you can run this. Okay, so the Python API itself, you're going to see a little bit of this over the practical section. So we try to keep everything nice and high level. It doesn't get too bogged down in the details. So you can see, when you load up a grib file, for instance, you don't really need to know that it's grib. You just get something, and if you look at that example in the bottom left, you can say like, this is wind gust data. So the phrase WG greater than 22 gives you a mask where the values are greater than 22, and you can call a mean function and multiply things by 100. And in the background, Metview is reading all these grib messages from disk and doing the computations and writing new data back. And you basically work with it much the same way as you would work with numbers, but it's actually grib data underneath. In fact, one thing you're going to see is the fact we can also do native operations between model data and observation data, which is nice. And also, since one of the nice things, since we're in Python, you can also just extract NumPy arrays or pandas data frames or X arrays from your data and then pass them to SciPy functions if there's something there you need. Okay, then generations. So every icon can be converted into Python, and there's basically two ways you can do that. So the first way is what we see on the left-hand side. So the leftmost icon is the standard view of a contouring icon editor, where you're adjusting how things look. But if you click on the little Python button, then you get the middle view there, which is the Python equivalent code of what you've done in the user interface. And so you can copy and paste that into your Jupyter notebook or something. Or else you can also take your contouring icon and drop it into Metview's own Python editor, and then it also generates the same code for you. We have lots of examples on Read the Docs. In fact, you're going to be going there in a few minutes. We've got a big gallery full of kind of one-shot examples in a sense. This is how you do this very specific thing. All the gallery examples are self-contained as well, which is nice. So they all download. If you just run them as you get them, they download any data that they need, and they should just work out of the box. And then we've also got a set of Jupyter notebooks, which are a little bit more tutorial based, you could say. They kind of tell a bit of a longer story, and kind of guiding you how to use things. And on top of that, we have some tutorials, a lot of which are a bit older, and some of them use macro languages as of Python. It's trivial to convert from macro to Python, but there's some quite nice stuff in there. So we've got something specifically about all the details of how to use buffer data, for instance. And yeah, there's a lot to explore. We're going to be doing one of these tutorials, in fact, in a moment. I think the last slide before we go into that is just to explain how you get it. So when we're inside ECMWF and we're running on Atos, like EC codes, if you just do module load ECMWF toolbox, then that exposes the Metview command to you, and you can run it. Some Linux distributions have kind of native binaries, the apt get install, zipper install, and so on. We're not in charge of those installations of Metview, but last time I looked, they're reasonably up to date. But two package managers we are in charge of. We do the Conda distribution, and you've got 3 Metview packages there. So Metview itself is kind of all of Metview, including the user interface. Metview batch excludes the user interface, so that makes for a much smaller installation. So if you really just want to use the Python bindings, then you would install Metview batch. And then the Python bindings themselves are a separate package on top of that, Metview Python. If you're running on the Mac, you can do brew install Metview. I think in theory on Linux as well, but I've never run homebrew on Linux. You can also build it from source. And then however you install the binaries, you can also do pip install Metview to get the Python bindings if you haven't done them from Conda. Next thing is that we go to GatherTown. And so your task, first of all, is to find Metview on Read the Docs. You'll want a browser tab open there. So once you found Metview on Read the Docs, if you can hopefully navigate these slightly strange instructions here to get to ECMWF new users Metview tutorial. So if you find Metview and read the docs, you want to go down the left-hand side and find tutorials. And then once you're there, you find the third one down is ECMWF new users tutorial. And at the top of the page, you should see something like this saying this is for the, well, new users. This course that you're doing this week has changed names, I think, over the years. This is intro to computing now, isn't it? But CommMars and CommIntro are different names for it. And so if we switch to GatherTown now, I will continue there. Okay, well, I hope most of you managed to get a reasonable little taste of what we can do. Of course, everything you see there is on Read the Docs and can be done at home or at work, or whatever, and whenever you'd like to do it. I just wanted to wrap up with a couple more slides. So first of all, here's some nice little pro tips. I think the command line tools, which I didn't discuss at all because it's only a short intro to Metview. If you liked the grib and buffer examiner, then you can actually start that up independently of a Metview session, as it were, just by typing Metview -e followed by the path to the file you want to inspect. So that's something I use quite often. In instances where I think maybe I want to call grib dump, I think, well, actually, Metview's examiner gives me all of that and more. That's a very nice tool. Metview -p, again, give it path to a data file, and it will plot it. So it doesn't start up a full Metview environment, so you can't then start editing the plot and dropping contouring icons into it because it's just a sort of standalone display window. But it's quite nice just for a quick look. Another thing that's quite useful is the -slog option. Stands for single log because Metview runs lots of different processes. But if you want all the outputs to appear together, which is usually the most useful thing to do, then you start Metview with -slog, then that gives you more to debug output. And particularly if you want to report some kind of problem to us, it's good if you've run it like that, because you might have some more interesting, useful information to give us. And the other thing, you may have noticed that Metview creates a directory inside your $home called Metview, where all your icons and files will live. If you want to use a different path, you can start up Metview with the -u option, which stands for user home or user directory, and then it'll use that instead. Support portal is generally the first port of call for asking questions, but if you look and read the docs, you'll find a lot of examples and everything's all hyperlinked usually. So if you go into a gallery example, you can click on the functions and get the API descriptions, and under the API description of each function, you get a list of all the gallery examples and notebooks that use it. I mean, that's a bit Python-centric, but it works as well for the user interface. And then finally, I wanted to say something, because if you're going to be working with ECMWF for a while, over the next few years, you're going to hear the term EarthKit being used quite a lot. EarthKit is it's an early development, but it is intended many years from now to be the successor to Metview. So it's kind of what you would get if you take Metview and split it apart into different components that are independent but still work together, but are a bit more focused. And if you replace a lot of Metview's C++ code with Python, then you get EarthKit. So we're kind of building it up with more sort of modern ideas in mind, trying to make it more scalable with your hardware, trying to make it more friendly with GPUs, that sort of thing. So it's still very much in early days. EarthKit data is the most mature of its components. But yeah, we've got a big list of all the Metview functionality that we want to be able to support ultimately in EarthKit, and that's going to be some years down the line. But since it's a big development in progress, we sort of tend to be advertising it quite a bit at the moment because we want people to contribute to it. So that's one of the nice things about it being Python. We're more likely to get collaborations with people to work on it. So yeah, so hopefully in some years' time, the things you're doing in Metview will be doable in EarthKit. That's also another good reason to be using Metview Python instead of Metview macro, because then you're in the Python world, and you can make a transition to EarthKit when that's finally ready. I think just be aware that that's on the horizon a few years down the line.